Hello, everyone, and welcome back to Channel Dad Bryon Lape reads about life and fitness. Now, this is something I came across. This is in the Irish Times. It is somewhat recent, last couple weeks. I thought this was a troll. When I saw this pop up as a suggestion I think it was on my tablet. Doesn't matter. I thought that surely this is a joke. This has been known for I don't know how many decades. I don't even remember the first time I encountered this, okay? All you really have to do is observe an elementary school PE class or a high school PE class and just observe it the whole year, right? Some kids can do 30 pull-ups easily. Other kids who look similar can barely do 2. And still am in that category, right? But then you have someone like me who's running medium distance, 600-yard dash or something, or a mile. Especially a mile. I'm one of the fastest kids in class. Not so fast running 100 meters. Unbelievable slow sprinter, but cranking out the distance. But anyway, enough about me. Okay, this is not a troll job. This is real. I kid you not. Study shows people's physiques react differently to the same exercise. Genetics may play less of a role than we imagine in our response. May play less. Okay, those two things counteract each other because your physique should be a measure of your genes. Okay, let's get to it because if you start exercising and do not seem to be gaining as much endurance or strength as you had hoped, you might want to switch up your routine. According to a fascinating, not just a new study, it's fascinating new study of exercise responders and non-responders. The study, which involved twins, shows that almost everyone responds to the right exercise programs, but the right exercise program can differ from person to person. The finding also indicates that genetics may play less of a role. Okay. This is the misnomer about genes. I mean, yes, they're twins, but what is their RNA response? That is what. Okay, let's get to it. The findings also indicate that, I already read that. The idea that people's physiques react differently to the same exercise might seem implausible at first. I'm sorry. It should be obvious. Most of us probably expect that when we begin a new walking, jogging, or weightlifting routine with friends or other training partners, we will also progress about equally. Okay. Again, if anyone has done this, if anyone has had them and their friend of theirs join a gym and they do the exact same routine. Okay, let's say that's two people close in strength. They don't even have to be twins. Okay, it's not like one's real skinny, one's 100 pounds overweight. Okay, this will happen once you get past that very, very early beginner stage where your body is like, whoa, what's this? And you get into the rhythm of the routine. It's weightlifting. One friend is going to be putting 5 pounds a week on. The other friend is going to be putting on the barbell. Okay, I'm not talking about weight. The other friend's going to be doing 10. And if there's 3 or 4 of them, there's going to be one person who for a month can't lift any more weight than they've been doing. And then all of a sudden one day they can double. Okay. But recent research indicates that our physical response can be idiosyncratic. After a few months of running, one person may gain considerable aerobic fitness, while another's endurance hardly budges. Yet. Just go watch basic training class. Go watch the Army. Ditto for weight training, in which some people build far more strength than others. No kidding. Even if they lift the same amount of weight. Yeah. And the thing is some people, and also depends on your age, some people respond very well to high volume. Some people don't. A few studies, though, have delved into what is wrong with my nose. A few studies have delved into whether people's responses are monolithic, meaning someone who barely responds to one kind of exercise will gain little from other types, or supple, so that swapping routines should raise response. The effect of genetics, likewise, has been uncertain. In some past studies, exercise response has seemed to run in families, with parents and siblings share similar physiological exercise gains or droughts. A potentially disheartening finding for anyone whose family history suggests low response. But those studies tend not to be experimental. They ask about people's exercise histories, but do not ask people actually to exercise while tracking whether and how they're okay. So That's a lot of self-study, self-reporting. Okay. So from this new study, which was published recently in the Journal of Physiology, researchers at the University of Western Australia in Perth and the University of Melbourne, although this is in the Irish Times, anyway, decided to study both the variable ability and genetics of exercise response by asking pairs of twins to work out together. Twins can be uniquely useful to science. Full disclosure, I am twin. Okay, I am not. The author, this was Gretchen somebody, right? Gretchen, I wonder, yeah. I guess these are twins. But see, even when I look at these two, okay, and granted, she's got tighter pants on. Their body shape is quite different. And their form is different. The young lady on the young girl, whatever, woman on the right has better form, seems to be holding back. Okay. Her body's more designed for sprinting. Her waist is thinner than the counterpart. Her legs, yeah. I would fully expect her to win the race. I could be very wrong, but whatever they're doing, I would expect seems to have better form. Has her feet under her too, better. Because identical twins share 100% of their DNA. While fraternal twins share about 50%. I don't think this is quite true. But yeah, maybe. Anyway, if twins try something new and the identical pair reacts almost identically and the fraternal ones do not, then the intervention has strong genetic component. If on the other hand, both identical not responding, just basically the opposite, then genetics is less fundamental to these responses than lifestyle factors such as people's diets, education, weight training. It all adds in there. Now, the researchers recruited 42 sets of young, healthy, and sedentary twins in Perth. 30 of these pairs, so several of the pairs believe they were fraternal, but genetic testing at the start of the study revealed that they, in fact, were identical, to everyone's surprise. See? Okay. But male, female. So we have a nice mix. Each of the set of twins worked out together for 2-3 month periods. During one, they ran or cycled for an hour 3 times a week. During the other, they lifted weights. It would be nice to know what kind of weightlifting they did. At the end of the twins returned to the lab and blah, 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 blah. They measured how legs and lungs had changed during. The results were telling. Most of the 84 participants increased their endurance during their 3. Oh, no kidding, but not all. Okay. So too, leg strength rose in most of the twins. I said, well, what did they do? After 3 months in the gym, but stayed relatively puny in a few. Almost no one, however, responded poorly to both endurance and strength training. In other words, you're going to get some benefit from it. These were very few recalcitrant non-responders. Who conducted Daniel Green with his doctoral students. Almost all these who yield, I don't really care about the titles and all that other nonsense, failed to respond to one form of training were capable of gaining benefit by switching to another. Interestingly, the benefit gained could be broad. In some cases, non-responders to aerobic exercise added endurance when they returned to weight training, even though lifting mostly targets muscles. In some cases, non-responders to aerobic exercise added endurance when they Mark Ripito has been saying this for decades, and people do not believe him. It's true, okay? At the same time, there was little evidence that genes shape people's outcomes because the twins responded varied widely But did their diets vary widely? The upshot, because a lot of this, essentially strength training, it really, your RNA response and your mitochondrial DNA response are what's going to determine what happens. Okay. And identical twins don't necessarily have, and now RNA, quite often gets, this is the nature versus nurture stuff, and nurture can change how that response happens. You don't need enough protein, don't get enough rest, strength training, you're not going to respond to. The upshot, there's so many variables here. The upshot, so to say that, maybe. The upshot of this data is that we should not be discouraged if prolonged running or lifting weights does not produce the results we hope. We might, in that case, want to noodle about with different approaches. There's an optimal exercise strategy for everyone, Green said, but it differs from people and will not be determined or limited. This isn't true. Okay, it will be determined and limited, but by how much? And everybody, the upshot of this is everybody responds differently. Period. I don't care if you're a twin or not. You respond differently. Of course, the study was short-term and limited to 2 types of exercise. There really are only 2 types of exercise. You're either building strength or building endurance. and you just monkey with those two variables, okay? Because nothing is 100%. Well, because it may be endurance. If you're long distance running, you're probably not building any strength whatsoever. And it can tell us that factors most influence other responders. If genetics do not, is it diet, mindset? It's all of that. It is absolutely all of that. Green and his associates hope to look into some. See, this is one of these things where people want to blame their genes for everything. And so they conduct a study like this, and it's, oh, well, our genes don't necessarily control us. Well, no kidding. Okay, not everyone reacts to exercise. Okay, so I know I'm being very snarky here, but I am so incredulous to believe that this was an actual study. Okay, because it's like, how is this an actual study? This is been known for a long time. People just need to get their head out of their butts. Your genes, this was the thing in the 90s. Finding genes for everything. Oh, this is the smoking gene. That's the fat gene. That's a this. That's a that. And yes, there is that component, but it is not the answer. There is not one thing. So, and if anyone knows the result of this race, or if this is just, for all I know, this is a stock photo and has nothing to do with the study, I would really like to know who's the faster of the two. Just by looking at them, this young lady looks like the sprinter. This looks like the medium distance runner. That's just my 200 meters. She wins half a mile longer. So 1,000 meter, or that would be a mile, I guess, couple kilometers. I think she wins. That's just my thoughts. All right. So what do you think of this study? Do you think I'm just, I don't want to sound like I'm making light of it. I just can't believe that this is real science, but you just go look at, like I said, go watch any high school, gym or just watch, follow a bunch of basic, recruits through basic training in the military. You'll see the exact same thing. So, all right. Thank you very much for stopping by, and we will see you. Goodbye. What about input? Input is okay. Just don't overwrite it. All right. All right. Yeah, I don't know. That's the problem with putting it on this browser. I got to make it really, really big and forget it. All right. 3, 2, 1.